All right, so in our previous lesson, we looked at how we actually calculate an inverse function, right? How we come up with that new equation. And we've talked about that x's and y's flip-flop, yes? So the domain of your original function becomes the range of your new one, your inverse. And the range of your original becomes the domain of your inverse. Yes? Your x and y's flip position. It says the inverse of a function is denoted with this notation. We read that the inverse of f, or f inverse, if we start with a function, so if we start with f of x, and we go and we calculate what that new inverse function should look like, it may or may not be a function. We can come up with a new equation or a relation, but it doesn't necessarily have to be a function. What was the test we had to see if something was a function? Vertical line test. So we could find the inverse equation, and when we look at its graph, it doesn't pass the vertical line test. Okay? We still have found the inverse, but we wouldn't call it a function. Does that make sense? All right, so first one here, it says consider the function f of x equals the square root of x minus 2. Can you picture the graph of that? Remember when we graphed square roots? It was kind of an endpoint with a curve, an arch? Yeah. Remember that? Okay, so what we have here has been a square root graph shifted where? Right 2. So instead of it being like this, right, we're going to have this. Okay, what would the domain of that green graph be? Okay, domain would have to be that x is greater than or equal to 2, correct? We're starting at 2 and going off to the right. What would the range be? Good, y is greater than or equal to 0. Now, you can give me that answer when it asks for domain and range. You can give me that based on what you know the graph to look like, or you can find it based on the equation. You can find it algebraically. If I were to find this algebraically, let's say I didn't know what the graph was supposed to be. We do know that what's underneath that square root symbol cannot be negative, right? So we know that x minus 2 has to be 0 or higher. And if I solve that for x, I get x being greater than or equal to 2. So I can find the domain of that whether I know what the graph looks like or not. It's just sometimes easier to visualize it. And if I know the domain has to be 2 or higher, could I start plugging some numbers in like 2, 3, 4, etc. and see what kind of y values I'm getting out? We're going to get 0 and numbers higher than 0. That would help us find that. Okay? But again, if you can kind of pair the graph with it, I think it'll make more sense for you. All right. So we found the domain and range of our original function. Now it says to come up with the inverse. To find the inverse, we said we're going to flip-flop the x and y, switch them. Right now, this is y, correct? F of x is just another way of saying y. So we have y equals the square root of x minus 2, and we want to switch those. So now it becomes x equals the square root of y minus 2. How do we solve that for y? We have to square both sides. And then add the 2 over. So we end up with x squared plus 2 equaling y. Okay. What is the domain and range of that inverse? We know domain and range of our original ones, correct? That means we just flip them. So if we knew that y has to be greater than or equal to 0 for my original one, I now know that x has to be greater than or equal to 0. And if we knew that x had to be greater than or equal to 2, now we know y has to be greater than or equal to 2. My domain and range just flip. Okay? So I want you to picture the graph of this inverse that we just came up with. If I just said y equals x squared plus 2, what picture comes to mind? A parabola, yep, that's been shifted where? Up 2. So if I didn't have all of this other stuff, if this is the only thing I saw, I would say that's a parabola that's been shifted up 2, and it would look like this. Yes? But I have to base it off of my original function. I'm trying to find the inverse of that original function. The original function had domain and range restrictions. The inverse now has domain and range restrictions. And we came up with this, that x's have to be greater than or equal to 0. Well, if I look at my graph, that's saying I can't go to the left of that line. My x's have to be over here somewhere. Yes? So my actual answer, if I were to graph this, combining the equation here with what I know for my domain and range, my actual graph would just be this half of it. And remember last week we talked about taking a picture and reflecting it over y equals x to see its inverse? If I started with this green graph and I reflect over this line, I'm just going to get that part of it, right? That's the mirror image of that. Does that make sense? So you have to be careful when there's domain restrictions on your original function. It's going to lead to some changes in your inverse function. Okay. All right. Would this pass a vertical line test, the blue one? Okay, so we would say that it is a function, and the reason for our explanation would be it passes the vertical line test. Okay. If you know that your inverse is a function, what I would do for my final answer, instead of having this be a y here, I would rewrite that as f inverse. So my final answer, I would say, is the inverse of function f is x squared plus 2 with these domain restrictions. Okay? So it's not the whole parabola, it's just the right half of it. All right, let's try another one. We have a function g of x being 6 minus 4x. We're asking you to do the same things. Find the domain and range, find the inverse, and then find the domain and range of that inverse, and decide if it's a function or not. So, talk at your tables. What shape is my original graph? G of x equals 6 minus 4x. What would it look like? What do we think? What shape? A line. What's the slope of that line? -4. So we have a negative sloping line, right? Slope is -4, y-intercept is 6. So are there any domain or range restrictions for a line? Okay. So for part A, my domain is all reals, and my range is all reals. Whoops, y equals. We okay with that? All right. Second question says, now find the inverse of it. Okay, so we started out with y equals 6 minus 4x. We're going to switch x and y. What steps would I have to take to get y by itself? Just solve for y. Okay, step 1, I'm going to move the 6 over by subtracting it. Somebody else. What's my next step? Okay, if I divide everything by -4, I end up with -1/4 x. What do I get for -6 divided by -4? +3/2, 3/2, and that equals y. Is it a function? Okay, I graph that. It's a negative slope, right? -1/4 slope. Y-intercept is 3/2. So it is a function. And because of that, I'm going to use that inverse notation. My original function was g, so I'm going to say g inverse is -1/4 x plus 3/2. What would the domain and range be for my inverse? Still all reals, right? They were both all reals to start with, so flipping them doesn't change that. Okay? Questions so far? All right. When you are finding the inverse in a real-world application, we can't switch the variables. The first step of finding the inverse has been to switch x and y. But look at an example here. We've seen this formula before. What's it stand for? Area of a circle. Yes? When we see that, we know that the A stands for the area of a circle. We know that R stands for the radius. It doesn't make sense to now say, I'm going to make the area become the radius and the radius become the area. Okay? In this context, that doesn't make sense. So we don't switch them, but we do solve for the other variable. So instead of having it solve for A, we rearrange it and solve for R. Okay? That's the inverse function of this one. All right? But if you are given a context where they tell you what those variables stand for, it doesn't make sense to switch them. All right, so for our example here, it says we have this function, d equals 4.9 t squared. It represents the distance d in meters. So they're giving me a context here. It's the distance d in meters that an object falls in t seconds due to Earth's gravity. Find the inverse of this function, then determine how long in seconds it takes for this cliff diver to reach the water below. First step, we want to find the inverse function. So I start out with d equals 4.9 t squared. How would I solve that for t instead of having it solved for d? What would my first step be? Okay, so we're going to take distance divided by 4.9. That equals t squared. Then what would I do? And typically when we square root something, what do we have to put in front? We put a plus and minus sign in front, right? Because we want both options. But t stands for time. Can it take this cliff diver negative seconds to get to the water? No. So in this context, we would not put the plus and minus in front. Okay? It's kind of like saying before, we had half a parabola, right? We just get the one part of our square root graph. Now that we have our inverse function, can we figure out how long it's going to take? We are told that it's a 24-meter distance from where they are to the water. So can we put 24 in there for d? All right. So t equals the square root of 24 divided by 4.9. Go ahead and use your calculator. What do we get? Anybody? 2.21. What units would we put on that answer? Seconds. Good. All right. So typically, if you are just given a generic equation, you'd switch x and y. If you're given a context like this, you wouldn't switch them. Okay? You're just going to solve for the other variable. All right. The last part that we're going to look at involves doing some compositions. It says, you know that for any function f, each x value in the domain corresponds to exactly one y in the range. For something to be a function, every x has to be paired with a single y, right? That's what allows it to pass a vertical line test. For one-to-one functions, it works backwards as well. In other words, every x is paired with a single y, and every y is paired with a single x. If you have that one-to-one function, or one-to-one relationship, then both the original and the inverse will be functions. They both would pass a vertical line test. Okay? When we do a composition, if we are composing a function with its inverse, what's going to happen is whatever operations the function does, the inverse is going to undo those. So if your original function says I'm going to add 5, your inverse is going to say I'm going to subtract 5. I'm going to cancel that out. Okay? So when you compose something with its inverse, what's going to happen is you're just going to get plain x out. All the things that the function did to x are going to get undone. And that works both directions. Typically, when we say you do a composition, we say it's not commutative, right? F of g and g of f are not the same. If the two functions are inverses of each other, you will get the same thing both ways. Okay? In purple here, I put down just a reminder. When we start talking about the domain for compositions, we look at the function that's getting dumped in, any domain restrictions on this inside function, and then anything in our final answer. Okay? Well, if our final answer is just going to be an x, we don't have domain restrictions on that. But we would have to worry about anything on that inside function. Okay? All right. Let's look at question 6 here. We are given the function f of x equals 1 over x minus 1. They are asking me to find the inverse of it. They are asking me to do two compositions, both directions, and evaluate them both for a 1. Okay? So we're going to do this in steps. Step 1, let's figure out the inverse function. Okay? So right now I have y equals 1 over x minus 1. There's no context to this equation, so we are going to switch x and y out. So I have x equals 1 over y minus 1. How would I go about solving that for y? Our y is in the denominator. How do we get it out of the denominator? Multiply it to the other side, yes? Or another way of saying that is you can times both sides by y minus 1. That'll bring it from the denominator out. All right, so we end up with y minus 1 times an x on the left. On the right-hand side, those drop out, and we just have a 1. Do not distribute the x in. We're trying to get y by itself. We don't want to put more stuff with y. So we're going to divide this over. So now we have y minus 1 equals 1 over x. And then my last step would be to add a 1 to this side. Okay. That is my inverse. Do you guys remember from exponential algebra what this equation would have looked like, what the graph would have looked like? If you don't remember, somebody at each table, just go in and graph y equals 1 over x. Y equals 1 over x. What does it look like? Once you have it, show the people at your table. You should be seeing something like that. Yes? Has 2 branches to it? Okay. What did we do? What kind of transformation would this minus 1 have done to that? It's in with the x, correct? Numbers in with x, move it left and right. So this moves it right 1. So my picture for the original function, we've moved it right 1. So now we're going to have a picture like this. Okay? The whole thing's just been shifted to the right 1. What value for x do I have to restrict in my domain for this? X can't be a 1, right? If I put a 1 in there, the denominator becomes 0, and I'm not allowed to divide by 0. So my domain restriction here is x can't be a 1. And what that is in my graph is something called a vertical asymptote. We're going to be talking more about those after in Chapter 8. What does my inverse look like? We know what 1 over x looks like, right? It's the blue graph here. Which way have we moved it? We've moved it up 1 this time. So now I have this kind of picture. And now I have what we call a horizontal asymptote at 1. Okay? My vertical asymptote would still be here at 0. So looking at this, what domain restrictions do I have? So my original function had a domain restriction of 1. My inverse has a domain restriction of 0. Okay? Is it a function? Does this red graph pass a vertical line test? Okay, so I'm going to say my inverse function is 1 over x plus 1. It does pass a vertical line test. These branches, even though they look vertical, they're not perfectly vertical. They're getting closer and closer to that y-axis. They aren't perfectly vertical, so it would pass a vertical line test. Okay, so we have a picture of what our original looks like and what our inverse looks like. We are going to do our 2 compositions, and I'm going to go through this first, pretending this is just an x instead of a 1, okay, like we did last week. So this one is saying start with function f, and inside it you're going to dump the inverse function. Okay, well, function f was 1 over something minus 1, correct? And we said our inverse is 1 over x plus 1. So what happens? We have 1 over x plus 1 in the denominator, as well as a minus 1 in the denominator. What's going to cancel out? Those 1s. So this becomes 1 over x. These undo each other, right? I'm adding 1, I'm subtracting 1. Cancel each other out. How do I get rid of dividing by a fraction? How do I clean that up? Multiply by the reciprocal. So the reciprocal of this would be x. So I'm going to multiply both top and bottom by x. This just becomes a 1, and the top becomes an x. Okay, so did it work? Did my two functions undo each other? Yes, I got a plain x. Okay. They asked me to evaluate it at 1, correct? Is 1 an allowed number? In other words, when I look at my domain issues, I have to focus on the function I dumped in, correct? So I'm focusing on this piece here. Can I put a 1 in that? Yes. Yes. If I put a 1 in that, I get 1 divided by 1, which is 1, plus 1. I'm at 2, minus 1. I'm back at 1. And this top 1 divided by 1 is 1. I'm supposed to just get x, right? So did it work? I put a 1 in and I got a 1 out? All right, so that was f of the inverse. Evaluating it for 1, we just get a 1. All right, let's look at our other one. This one says start with the inverse and dump the original into it. Again, I'm going to do this just with an x. Starting with the inverse, we had 1 over something plus a 1. What were we dumping in? The original function, right? 1 over x minus 1. How do I get this flipped? I have to multiply by the reciprocal, yes? So I'm going to multiply x minus 1 to the numerator and denominator here, which means I'm going to end up with x minus 1. Then it says I'm supposed to be adding a 1. So I end up with x. But notice that those things canceled in a different order. In the first example, the 1's canceled first, and then I cleaned up the fraction, dividing by the fraction. Here I had to clean up the fraction first, and then the 1's canceled. Okay? The last part, it says to find f inverse of f of 1. So I go back here, and it's saying I'm supposed to be putting into this original function, I'm supposed to be putting a 1. Can I do that? No. I could pick any other number. If I changed this to anything other than a 1, I'd be able to do this question. But for a 1, that was our restricted value in this inside function, I can't do it. There's no solution to that part of it. I can still do the composition and show that everything drops out, but I can't evaluate it at 1. All right, questions on that? All right. Question 7, for each function, find the inverse. Find the domain and range of the original and its inverse and determine if it's a function. I'm going to pause the recording. I want you guys to talk about this at your tables. All right, let's start out with domain and range of my original. Any restrictions? Okay. What shape is this? It's a parabola? Then shifted where? Okay, so if we visualize it, a parabola that's been shifted up 3 is going to look like this. So there's no domain restrictions, but there is a restriction on range. What's my restriction for the range? Okay. Because my lowest point is here at 3, none of my y values will ever go below that. Okay? Then I have to find the inverse. So we start out with y equals x squared plus 3. We switch them. And then what do I do? Subtract the 3 over, and then what? Now, when I square root, do I need to include a plus and minus in front? I do. I started out with the whole parabola. That means I'm going to get the whole square root part. Okay? All of it. Is it a function? For that, we need to think about our graph. The first one is a function, correct? This passes a vertical line test. They gave me this indication that it was a function. The question is the inverse also a function? And if I were to graph this, it is a square root graph that's been shifted which way? Right 3. But there's a plus and minus in front. So I'm going to go right 3 and have a positive square root graph. But I'm also going to go right 3 and have a reflected graph, right? That negative in front is going to cause me to have this as well. So my inverse is not a function. And if they ask why, if it says explain why, you would say what? Fails vertical line test. Okay? What would my domain and range be for the inverse? Okay, and range? Right? I'm just going to flip-flop these two. Anytime you do the inverse, your domain and range of the original flip-flop. So a lot of times it's easier to figure out the domain and range of the original than to try to analyze your inverse one. All right, unless you have a graph. If you have a graph of it, it's not so bad. All right, last one. We're going to go through this one together because this one has a little transformation that you haven't seen before. When I look at this, algebraically, if I tried to find the domain, I need to find what makes that 0 or higher, correct? I can't have it be negative. So I'd start out saying negative x plus 5 has to be greater than or equal to 0. If I subtract the 5 over, I get this. How do I get rid of the negative in front of the x? I divide out a negative 1. What happens to my inequality when I divide by a negative? It flips. So I am saying that my domain has to be 5 or lower for this to work. Okay? Could we plug some numbers in and make sure that's right? What happens if I put a 5 in there? I get 0. If I put a 4 in there, I get 1. If I put a 3 in there, I get the square root of 2, right? Put a 4 in there, I get the square root of, put a, what are we at? A 2, I get the square root of 3. So if I start putting in 5, 4, 3, 2, 1, my answers out are 0 and higher. So my domain is that, my range is that. All of the answers that I'm going to get out for y are going to be 0 or positive. Okay, now I'm going to explain graphically what would have happened here. Again, we haven't done this type of transformation yet. You'll get to that next year. When we are trying to graph y equals the square root of negative x plus 5, to identify the transformations, we have to pull that negative away from the x. Okay? So to do that, it's still inside, but I'm going to divide a negative out of these two pieces. I'm going to get a positive x minus 5. And what happens, this is a right 5 move. This, because it's inside that square root symbol, it's actually going to be a reflection over y. We haven't done any y-axis reflections, but that's what would happen. So graphically, I would start out with my square root graph. I would reflect it over y. Now it looks like this. And then I'd shift that whole thing right 5. So this would be my result. Does that make sense? So do our domain and range fit what I'm picturing? My x's are 5 and lower. My y's are 0 and higher. Okay? Let's go ahead and find the inverse. We're going to switch our x and y's here, so we have x equals the square root of negative y plus 5. What do we do first? Square both sides. Somebody else. Subtract a 5. How do we get rid of the negative that's by that y? Divide everything by a negative. So this x squared becomes negative. The negative 5 becomes positive. Okay? Can you visualize what that graph is? It's a parabola that's been done. What have we done? It's opening down, right? We flipped it, and then we moved it up 5. So picturing it, we're up here at 5, and we have an upside down parabola. But do we have the whole parabola? What is the domain and range for my inverse? I have to take these and flip them, right? So y has to be less than or equal to 5, but x has to be greater than or equal to 0, which means I'm only going to have this part of it. Does that make sense? That wouldn't be included. So if I start out with just a square root graph, 1/2 of it, the positive version, I'm only going to get 1/2 of my parabola out. Okay? All right. Yep. All right, so homework. You are going to do 31 to 39, 42 to 47, 51 to 56.